Hey guys, Mr. Backwork here. In this video, we're going to look at row echelon form of a matrix. Now, we've already looked at getting row echelon form with a system of equations. Before we get to doing row echelon form with a matrix, I first want to talk about something called an augmented matrix. So in front of us, we have a system of equations, and we can actually take that system of equations and turn that into something called an augmented matrix. Now, before we start building our matrix, we want to make sure that all of our variables are in the same position within each equation. So all of my equations go x, y, and then z. So then what we're going to do is we're going to look at this top equation, and I just want to focus on the numbers. So the number with the x in front is 3. So I'm going to take that 3 and I'm going to put that as the first entry in this matrix that I'm building. The number in front of that y is a -5, so I'm going to take that -5 and put that as the second entry in this top row. Now there's not really a number in front of this z, which means there's a 1, so I'm going to put 1 as the third entry in this top row. And then our equals to is that 14, so I'm going to put that as the fourth entry in this top row. And I'm going to do that with all of my equations. I'm going to look at the numbers involved in each equation. So in my second equation, the number in front of the x is a 1. The number in front of the y is a -2. The number in front of the z is a 1. And then my equals to number is 7. And then in my bottom row, the number in front of the x is a 2. The number in front of the y is a -2. The number in front of the z is -1. And our equals to information here is 3. So this matrix came from those numerical values from our system of equations. We've essentially just gotten rid of the variables and we're just focusing on the numbers. And that's actually what we're going to look at doing as we're taking a matrix and putting it in row echelon form. We're going to start with a system of equations. We're going to turn that into a matrix and then perform operations on that matrix to get it in row echelon form. So let's talk about what a matrix in row echelon form looks like. And I've got an example of a row echelon matrix in the top right-hand corner here. But a matrix is in row echelon form if these three conditions are met. And the first one is that any row containing all zeros has to be at the very, very bottom. Now this matrix doesn't have any rows that contain all zeros, but if it did, they would be across the bottom here. Now, number 2 says the first non-zero entry in each row is a 1. So in this top row, we've got a 1 right here. In our second row, we lead off with a 0, but then the next number is a 1. In our third row, we've got a couple of zeros and then a 1. So the first non-zero entry in each row is a 1. And then 3 is a little tricky to think about, but it says for 2 successive non-zero rows, so any rows that don't contain all zeros, the leading one in the higher row is further to the left. So what that basically means is that we've got a stair-step pattern happening with those leading ones, a lot like we saw with that stair-step pattern in a system of equations. Similar things are happening here. Similar to when we were putting a system of equations in row echelon form, there are certain operations that we can perform with the rows of our matrix in order to yield an equivalent matrix. And the first operation is that we can interchange any two rows. Number 2 says that we can multiply or divide a row by some non-zero constant. And then number 3 says that we can add a multiple of one row to another row. So in this example, this is that system of equations that we were looking at earlier, and we already found its augmented matrix. Now what we're going to do with that matrix is work on putting it in row echelon form. So we're going to be performing those elementary row operations with this matrix over here, and we're going to be building a new matrix that's in row echelon form. And I'm going to build that down in the bottom left-hand corner here. Now we said with that top row, we wanted to lead off with a 1. And right now our top row is leading off with a 3. But if we look at our second row, that row leads off with a 1. And one of our operations said that we could rearrange the rows of our matrix. So I'm going to take this second row and I'm going to move it up to the top. So then my matrix is going to lead off with 1, -2, 1, 7 across the top row. And I like to put a mark next to that row in my original matrix so that I know that I already used it in my new matrix, because we don't want to reuse a row. Now for our second row, that leading 1 needs to move further in, and we actually want to lead off with a 0 and then have a 1. So I'm going to look at this top row, this 3, -5, 1, and 14 row, and I want to think about what I can do to that 3 to turn it into a 0. And we want to think about elimination type of things. So something that I could add to a 3 to turn it into a 0 would be a -3. So I want to think about doing some sort of multiplication with a different row so that it leads off with a -3. And I'm looking at this middle row right here, and what I'm going to do is multiply everything in that middle row by -3. So -3 times 1 gives me that -3 that we were looking for. -3 times 2 is +6. -3 times 1 is -3. And then -3 times 7 is -21. Now when we add these rows together, the 3 and the -3 make 0. -5 and 6 is 1. 1 and -3 is -2. And 14 and -21 gives me -7. So I'm going to fill that in as my second row in this matrix over here. And then I'm going to put a mark next to that row so that I know that I've already used it. And then we're down to this last row here, this 2, -2, -1, 3 row. And in row echelon form, we want this row to go 0, 0, and then have that leading 1. So the first thing I want to look at doing is getting rid of that 2, zeroing out that 2 in the first column. So in order to get rid of that 2, I'm going to need a -2. So similar to what we did in the previous step, I'm going to take this middle row, but instead of multiplying by -3, I'm going to multiply by -2. So -2 times 1 gives me that -2 that we were looking for. -2 times -2 is +4. -2 times 1 is -2. And then -2 times 7 is -14. Now when we add up these two rows, 2 and -2 makes 0. -2 and 4 makes 2. -1 and -2 is going to give me -3. And then 3 and -14 is going to give me -11. Now in my next step, I need to be careful because I want that first entry to stay as a 0. So I need to be very careful about the row that I use next to help me zero out that second entry. So I'm actually going to look at this new second row that we ended up with over here, this 0, 1, -2, -7 row. And in order to get rid of that 2 in the second entry, we need a -2 there. So I'm going to take this new row that we ended up with before and multiply by -2. So -2 times 0 is 0. That's going to be helpful because when we add those together, that will stay as a 0. -2 times 1 is going to be -2. -2 times -2 is +4. And then -2 times -7 is +14. When we add up this 2 and this -2, we're going to get 0. -3 and 4 gives me 1. -11 and 14 gives me 3. So now I'm going to fill this in as my third row since we've got that 0, 0, 1. So this matrix is now in row echelon form. And one purpose for getting a matrix in row echelon form is to be able to solve the original system of equations. So as we're taking a look at this matrix, I'm actually going to fill the variables back in now, and I'm going to start with the bottom. So this 0 right here, well, our first variable was an x. That would mean that we have 0 x's. This second 0 means that we have 0 y's. And this 1 right here means that we have 1 z. So that bottom equation is really saying z equals 3. Now in this middle row here with that 0, 1, -2, -7, we've got 0 x's, we've got 1 y, we've got -2 z's, and this is going to equal -7. And then in this top row, we've got 1x minus 2y plus z equals 7. And now what we can do with this is back substitution like we looked at doing with a system of equations. So since we know that our z value is 3, I can take that 3 and plug it into this second equation here to help me solve for my y value. So we would have y minus 2 times 3 equals -7. Now -2 times 3 is -6, so we have y minus 6 equals -7. If we add that 6 over to the right-hand side, then we're going to get a y value of -1. And then I can take that 3 and that -1, fill them in for z and y in this third equation so that we can solve for our x value. So this would say x minus 2 times -1 plus 3 equals 7. -2 times -1 is +2, so x plus 2 plus 3 equals 7. 2 plus 3 is 5, and if I subtract that 5 over to the other side, I get x equals 2. Now we've got the solution to our system of equations. Our x value is 2, our y value is -1, and our z value is 3. So I'm going to write that as an ordered triple. My x value is 2, my y value is -1, and my z value is 3. So that's the solution to this original system of equations that we were working with. That's going to be it for this video. Thanks for watching.